Today we're going to talk about position and velocity time graphs and how to read them to determine where different motions of objects, okay? So the very first thing, slope on a position time graph represents, okay, so if you have a position time graph, then that slope is the velocity, okay? The curvature on a position time graph would represent the acceleration. So is it curving up or curving down? That will represent how much acceleration there is, okay? So that's acceleration. And then the slope on a velocity time graph represents acceleration, okay? So what's confusing to a lot of students is that we're using slope, right, for two different things. On the position time graph, it's velocity. But if we're looking at a velocity time graph, then the slope has to be the acceleration, okay? All right. So for this first graph, we look at it, okay, and we see that it is increasing, and we read it going from left to right. So we always read it going this way. So if you look at this, it's increasing, all right? So increasing, and we have a position time graph, that would tell us that the slope is positive. So if you pick any 2 points on this curve, the slope would be positive, all right? And then if we know the slope, and this is the position time graph, and we know the slope is positive, that automatically therefore tells us that the velocity is also positive. So velocity is positive, okay? Now, the curvature of this, so it's bending, and you can see the curvature is up. So that, let's just say curving up. Okay, so the curvature on a position time graph will tell us the acceleration. So since it's curving up, that tells us that the acceleration is positive. Okay, and therefore, since we know that the velocity is positive and the acceleration is positive, then that would mean the object is speeding up. Whatever that object is speeding up. So looking at this graph, we can tell it's speeding up on this interval. All right, next one. So this is still a position time graph, and we look at this and from left to right again, and we can tell that it's again increasing. So we see it's increasing. All right, and since it's increasing, that tells us that the slope is positive. And because the slope is positive and we're dealing with a position time graph, that slope is also the velocity. So we know the velocity is positive. Now, this time it's curving down, it's bending down. So curving down. There's a math term for this. It's called concavity, but you don't have to worry about that. Okay, so it's curving down, which tells us, because the curvature of this graph will tell us the acceleration for a position time graph. So since it's curving down, that tells us the acceleration is negative. Okay, so since the velocity is positive and the acceleration is negative, they're opposite signs, and that tells you it's slowing down. So the object, whatever it might be, is slowing down. All right, next one. Once again, we read this from left to right, and reading it to left to right, now this is decreasing. Okay, and since it's decreasing, that tells me the slope of any point on there is negative. Okay, this is a position time graph, slope is negative, therefore velocity is negative. All right, now the curvature. Now, once again, it's curving down. It's bending down. So curving down. And if it's curving down, that tells us that the acceleration for a position time graph, that if it's curving down for a position time graph, then that tells us the acceleration is negative. Since the velocity is negative and the acceleration is negative, that tells us that the object is speeding up because of the same sign. All right, next one. And what I'm doing is I'm going through the 4 situations that can happen with increasing and decreasing and the curvature of the graph. So for this one, once again, it's decreasing. Since it's decreasing, the slope for this graph is negative. Since the slope is negative, and this is a position time graph, this is telling me that the velocity is also negative. And if you look at this, it's the curvature is it's bending up or curving up. So curving up. Since it's curving up, that tells me that the acceleration, because this is a position time graph, the acceleration is positive. So since the velocity is negative and the acceleration is positive, that's telling me this is slowing down. The object is slowing down. All right, so those are the 4 situations for a position time graph for looking at both the velocity and the acceleration from just looking at the graph. So what we're going to get into next is I'm going to look at 2 graphs, a position time graph and a velocity time graph. And I'm telling you right now that each of these pairs that go together are showing the same type of motion. All right. So if you look at this, all right, we're looking that this isn't increasing or decreasing. All right. It's that the slope is 0. And so if the slope is 0, okay, that means the velocity, because on a position time graph, the velocity would also have to be 0. So what I should have said this at the very beginning, all right? These are 2 examples, one from position time graph and one a velocity time graph where the object is not moving. So I should have said that at the very beginning. Object is not moving. Now think about this. On a position time graph, if you look at this, all right, it's staying in the same position. So for all of these time values, right, the position is not changing. It's not going up. It's not going down. It's staying the same. It's constant, right? So the slope is 0. That means the velocity is 0, okay? How that shows up over here is that the graph lands on top of the horizontal axis. So that's where this velocity is 0. Up here, velocity is positive. Down here, velocity is negative. Right on the axis, the velocity or the y values are all 0, okay? So this is on the horizontal axis. The graph is on the horizontal axis. Okay, and that's what's telling me on this one that the velocity is 0. So for both of these, the velocity is 0, but for different reasons. This one, because the slope is 0. This one, because it's on the horizontal axis where the velocity is 0. Okay, now there's no curvature to this, right? It's not bending up, it's not bending down, it's doing neither. That also means that there's no curvature. So what that means is the acceleration is also 0. So over here, the slope for a velocity time graph is the acceleration. So the slope of that line is 0. All horizontal lines have a slope of 0. Okay, so that's telling me that the acceleration is 0. Okay, so both of these describe an object that's not moving, okay? Both of them have 0 velocity and both of them have acceleration that's 0, but we read off the graph 2 different ways. All right? All right, let's go to the next one. So this is a position time graph and this is a velocity time graph, and it's actually showing the same exact motion, okay? And what that motion is, it's the object is moving at a constant velocity and also moving in the positive direction, okay? So the object, and I'll show you how to read it and know this in just a minute. So for both of these, the object is moving in the positive direction with constant velocity. All right, so if you look at this, all right, this is increasing. Since it's increasing, that's telling me the slope is positive. And because this is a position time graph and the slope is positive, slope is velocity for a position time graph, that's telling me velocity is positive. Now it's that part right there that's telling me it's moving in the positive direction. So if this was moving left and right, we would be moving right. If this was an object that was moving up and down, we'd be moving up in the normal way we align things, okay? Over here, the way we can tell that the velocity is positive is the graph is above the horizontal axis. So graph is above horizontal axis. Okay, so all of the outputs for this, the outputs are the time and the outputs are velocity. Since all the outputs are above, that means all of these are positive, all right? And that would mean the velocity is positive. Okay, now the acceleration, there's no curvature to this, right? It's a straight line. So what that means is if there's no curvature, that means there's the acceleration is 0, okay? So no curvature. That's telling me on this graph that the acceleration is 0. Over here on this graph, all right, slope is what gives you acceleration. So if you look at the slope of this line, this is a horizontal line, right? So the slope is 0, which in turns tells me that the acceleration is also 0, because for a velocity time graph, slope and acceleration are the same thing. All right. So that's how I know, okay, this is the acceleration is 0, which means if there's no acceleration, that means there's no change in the velocity. So the velocity must be staying the same, and it's a constant velocity. Okay. So the velocity is not changing. That's why we say it's a constant velocity, because the acceleration is 0 for both these. But once again, they're describing the same motion, but 2 different ways, right? This is from the slope has given us velocity and the curvature gives us acceleration. Whereas if on a velocity time graph, we're looking for where the graph is either above or below to determine the velocity sign of it. All right. And then to determine the acceleration, we're looking at the slope of it. Okay. So these two graphs right here, this position time graph and also this velocity time graph, are describing an object that's moving in the negative direction with a constant velocity. So the object is moving in the negative direction with constant velocity. So if you look at this graph, position time graph, right, we're going to get velocity by looking at the slope. The slope, this graph is decreasing. That tells me the slope is negative, which in turn tells me the velocity is negative. All right, over here, the graph is below the horizontal axis, which is telling me all these velocity values are all negative, okay? So we know that the graph is below horizontal axis. And because it's below, all the values below are all negative. So this graph, the velocities all have to be negative. Now acceleration, once again, there's no curvature to this. So no curvature. That's telling us the acceleration is 0. Okay, over here on a velocity time graph, the acceleration is determined from the slope. Then the slope of this line the line is horizontal, which means the slope is 0. Okay, and the slope for a velocity time graph is acceleration. So that means the acceleration is 0. All right, so that in essence, that tells us the object is moving in the negative direction, okay, because the negative velocity, and then it's not speeding up or slowing down because the acceleration is 0. So we're not adding to the velocity and we're not removing from the velocity. The velocity is just staying the same. So these two graphs, the position time graph and velocity time graph, they are both telling us that the object is speeding up and also moving in the positive direction, okay? So the object is speeding up and moving in the positive direction. So if you look at this graph, position time, we see it and it's increasing. Which tells me slope is positive, which tells me velocity is positive. Over here, the graph is above the horizontal axis. And because above the horizontal axis, I can tell that the velocity is always positive. I can't spell velocity. I've been spelling it too many times. All right, velocity is positive. Now for the curvature. Now this is curving up. So curving up, bending up, that tells us that the acceleration is positive. For this one, we look at the slope for the velocity time graph to determine the acceleration. We got to look at the slope. This slope, since it's increasing, all right, that tells me slope is positive. And for a velocity time graph, the slope is acceleration. So this is telling me since the slope is positive, the acceleration must be positive. So because velocity is positive, that means we're moving in the positive direction. And since both velocity and acceleration are the same sign, that tells us we're speeding up. So these two graphs, the position time graph and velocity time graph, are both telling us that the object is moving in the positive direction, but it is slowing down. So the object is slowing down and moving in the positive direction. Okay, so how do I know that, right? How am I looking at this and I know that? Well, I'm looking at this and I can tell that this is increasing, all right? Which if it's increasing, that would tell me the slope is positive. Which since the slope is positive and we're looking at a position time graph, that slope is velocity. So the velocity is positive. Over here, we're looking at velocity time graph, and all of these values are above the horizontal axis. So that tells me that all of these velocities are positive. All of these values, all these outputs are positive. So we're looking at the graph that's being above horizontal axis, which tells me the velocity is positive. Okay, now curvature, the curvature of this is curving down. And since it's curving down, that's telling me the acceleration is negative. Over here for velocity time graph, the acceleration is determined by the slope. We look at the slope here. This is decreasing. Which tells me the slope is negative. And the slope, once again, for the velocity time graph, that slope is the acceleration. So the acceleration is negative. So because their velocity is positive, that's why we're going in the positive direction. Since these are opposite signs, that's how I know it's slowing down. This position time graph and this velocity graph are also describing the same motion. And so to read these, okay, I can tell, all right, because I've been doing this for a while, all right, that this object is slowing down and moving in the negative direction. So let's write that. The object is moving, well, actually, I should say slowing down. The object is slowing down and moving in the negative direction. All right, so you look at this, it's decreasing. Since it's decreasing, that tells me the slope is negative. Because the slope is negative and we're looking at a position time graph, then that tells me the slope is the velocity, so the velocity is negative. Let's come over here. Okay, so now you look at this graph, the entire graph is below the horizontal axis. And since we're looking at velocity time graph and the graph is below, that means all of these velocities are negative. So that's what's telling me I'm moving in the negative direction. Over here, I'm looking now at the curvature of this. It's curving up. And since it's curving up, it's bending up, okay, then that is, for a position time graph, that's telling me the acceleration, and that's telling me, since it's curving up, that the acceleration is positive. Over here, the way I determine acceleration from velocity time is that I look at this and I see that it's increasing. And so that's telling me the slope is positive, which in turn tells me the acceleration is positive. Okay, so how do I know it's slowing down? It's because the velocity and the acceleration are opposite signs. Once again, these two graphs are describing the exact same motion. So in this case, the object is speeding up in a negative and moving in the negative direction. Okay, so the object is speeding up and moving in the negative direction. Okay, so how do I know that, right? So I'm looking at this. I see that it's decreasing. Since it's decreasing, that tells me the slope is negative. And this is a position time graph, so this slope is also velocity, so that's telling me the velocity is negative. Over here, I'm looking at the graph of velocity time, and I'm looking at this graph, and it's completely below the horizontal axis. So graph is below horizontal axis. And because it's below the horizontal axis, that's telling me that all these velocity values, all the y values on here are all negative. Okay, so velocity is negative. Okay, now let's take a look at the acceleration. So the acceleration, this is curving down. On a position time graph, the curvature of it will tell me the acceleration, so, or the sign of the acceleration. So this is telling me, since it's curving down, the acceleration is negative. Over here, the way I determine the acceleration is to look at the slope. So I'm looking at this graph and I notice that it's decreasing, which tells me the slope is negative, which in turn tells me that the acceleration is negative. So because the velocity and the acceleration are both negative, they're both the same sign, that's how I know it's speeding up. And how do I know it's moving in the negative direction? I know it because the velocity is negative. So up to this point, we've written it all out, but now I actually want to talk about the motion, and I want to talk about like what's happening in every one of these segments. So segment A, segment B, segment C, D, E, and F, okay? All right, and this is moving along the x-axis. Okay, so because we now know it's moving along the x-axis, that means positive velocity would mean it's moving right, and negative velocity would mean it's moving left, okay? So let's talk about segment A first. All right, so segment A. Okay, so looking at this, I see that it's in segment A, it's increasing, right? Which means the slope is positive, which means the velocity is positive. So for segment A, we know that the velocity is positive. There's no curvature to this, right? So it's not curving up or curving down. That means the acceleration is 0 because there's no curvature. All right. So what this means is the object is moving to the right. So for segment A, the object is moving right. And the way I know that is because the velocity is positive. Now, there's no acceleration. So I'm not either adding or removing to this velocity. It is staying the same velocity the whole time. So the object is moving to the right at a constant velocity. Which means the velocity is staying the same. It's not changing. All right. So segment B, let's talk about that one next. You know what? And I should have said this. We are looking at a position time graph. So since we're looking at position time graph, we're looking at slope to determine velocity, and we're looking at curvature to determine the acceleration. I should have said that earlier. So segment B, we're looking at this, and we're looking at the slope to determine the velocity. Well, this is a horizontal line, and all horizontal lines have a slope that's 0. So for segment B, that means the velocity is 0. Also, there's no curvature. It's not curving up or curving down, so that means A is also 0. So for segment B, what that means is that this is the object is not moving. All right. Because remember what velocity is, velocity adds or removes distance. And since the velocity is 0, we're not adding or removing distance. So that means we're staying at the same spot. Okay. Or you could say it is stopped. Okay, so now segment C. Okay, so looking at segment C, I can tell that it is increasing, which means the slope is positive, which means V is positive. I can tell the curvature it's curving up, which means acceleration is positive. So when the velocity is positive and the acceleration is positive, that means when they're the same sign that we are speeding up. So the object is speeding up. And because the velocity is positive and it's moving right. Because right is the positive direction when we talk about moving on the x-axis. Okay, so now segment D right here. Okay, so segment D, I can see it's still increasing, which means the slope is positive, which means the velocity is positive. But now I can tell the curvature has changed and now it's curving down. So that means the acceleration is negative. And so because the velocity is positive and the acceleration is negative, they're opposite signs. That means the object is slowing down. And since the velocity is positive and it's moving right. Now, a lot of times, I won't say always, but a lot of times when you slow down, you wind up stopping, okay? So if you look at the slope right here at 8 for a moment in time, you see that's the top part, it rolls over. Right here, that velocity is 0. That's that slope right there at that exact moment in time at t equals 8. The slope is 0, all right, which tells you it's stopped. So at t equals 8, it's stopped. All right. And not for a period of time, not like B, but just for one split second, like a finger snap. All right. It stopped. All right. And so whenever you see it slowing down, I would look to see, did it stop right there? Okay. Now what happened next is for segment E right here. All right. I now see that it's decreasing, which means the slope is negative, which means the velocity is negative. And I can see that it's curving down. So A is negative. And so because the velocity and acceleration are the same sign, I know it's once again speeding up, but this time it's moving left. So before this, it was moving right, and now all of a sudden it's moving left. That means it changed directions, okay? So the object is speeding up and moving left. And then finally, this final segment, segment F. Let me slide this up a little bit. So segment F, I can see that it's still decreasing, which means the slopes are negative, which means the velocity is negative. And its curvature is curving up. So that tells me the acceleration is positive. Okay, since these are opposite signs, that's telling me it's slowing down. So the object is now slowing down. And moving left. All right. And all I want you to describe, like I want you to describe each of these segments, like what's happening on just that segment. Okay. Hopefully this is really starting to make sense for you. So now we're going to be looking at a velocity time graph and really doing the same thing, but analyzing this and saying, okay, what is this telling me? All right. So now to determine the velocity, since we're looking at the velocity time graph, we are looking where the graph is either above or below. Okay. And then to find the acceleration, now we're going to look at slope. Okay. Because the slope for a velocity time graph is the acceleration. Now, one thing right here at t equals 2, I want you to take a look at this. All right. Right there at t equals 2, that means the velocity is 0, which means the object is stopped, right? So stopped at t equals 2. We automatically know that just by looking at that graph, okay? Whenever it crosses the x-axis or the horizontal axis, right, then we know that it's stopped for a moment in time. Now, that's just a moment, like snap of fingers, it stopped, okay? Not like coming up to a stop sign and waiting, all right? That would be this one right here, okay? That would be an interval in which it stopped, okay? So looking at this right now, this segment A, this would be segment A from here to here. This is segment B. This is segment C, segment D, segment E, segment F, okay? So segment A is above, right? So since it's above, we know that the velocity is positive. So we know V is positive. All right. We also know that this is decreasing, which means the slope is negative, which means the acceleration is negative. So A is negative. All right, since these are opposite signs, that's telling us it's slowing down. And that makes sense because just before it stopped, it has to slow down, okay? So the object is slowing down. And moving right. Okay, so that's segment A. Segment B. Segment B, this segment, this graph is below, which is telling me all the velocities are negative. So V is negative. The slope here is, well, the graph is decreasing, which tells you the slope is negative, which tells you the acceleration is negative. Since these are the same sign, that tells you the object is speeding up. And because the velocity is negative, it's moving left. So it's speeding up and moving left. The next segment is segment C. It is below the horizontal, and so all of these velocities are negative, so that means V is negative. The slope for this line segment right here is 0, all right? So that means A is 0. Now, what does this mean? Well, there's no acceleration, right? Which means we're not adding or removing to this velocity. So that means the velocity is staying the same and it's moving left, all right? So the object, we would say the object is moving left at a constant velocity. All right, so segment D, it's also below, which is telling me the velocity is negative. So we know V is negative. Now this piece is increasing, which tells me the slope is positive, which tells me the acceleration is positive. And I don't think I've said this, but once again, how do we determine the acceleration? Well, for a velocity time graph, we look at the slope to determine the acceleration. So since the velocity is negative and the acceleration is positive, those are opposites. That means it's slowing down again. So the object is slowing down, and because the velocity is negative, and moving left. So it's slowing down and moving left. Segment E. Okay, so segment E is not above or below, and it's right on. So that's telling you the velocity for that segment, the velocity is 0. All right, the slope of this, well, it's a horizontal, right? So the slope is also 0. So that means A is 0. So if there's no velocity, and this is really what determines it, okay? The velocity is 0. That means the object is not moving. So it is stopped. And then finally, the last segment, segment F. Okay, so now we look at segment F. Segment F is above. All the velocities above are positive, so that tells me the velocity is positive. It is increasing, which means the slopes are positive, which in this case, because it's a velocity time graph, the acceleration is positive. And so because the velocity and acceleration are both the same sign, that tells me the object is speeding up. And the direction of movement is it's moving right. Because we're moving on the x-axis and the velocity is positive. All right, that's how you do these, guys. All right, you just go piece by piece through it. All right.